Now let's talk about compiling CUDA code. I'm not going to describe how to write CUDA code. This isn't a CUDA tutorial. So I'm going to assume you know how to write CUDA code if you're compiling for it. And this example that's included in the beginner's guide just does a simple matrix multiply on the GPU, does another matrix multiply on the CPU. It measures the time that each of those takes and then prints them to the screen. So the compilation, since we have these wrappers, is exactly the same. Use the capital CCC, and you can just copy and paste this into your terminal. And now we have an executable for the GPU. And we need to submit that to a queue, to the queue. We need to be on a machine with a GPU to run that command. And you can see, looks exactly like it did in the scheduling tutorial that we did earlier. And the capital CC wrapper here is handling the fact that, of course, it's compiling with the correct NVIDIA compiler and including the proper hardware configuration for our A100 GPUs. So you do not have to specify the GPU version that you want to compile for, or the compute compatibility, I guess is how you would say it in NVIDIA speak. That is included in this wrapper. Okay, so let's submit that job. And keep in mind, when you submit your jobs, submit them from the Polaris directory, because I have these scripts set up to dump your logs into the logs directory, just to keep things clean. So we're going to use that example submit script. I need to specify my project name. Oh, of course, I need to prefix with the examples directory. Okay, so it submitted that job. I can check the status of that job. I can see that it's running. It's very quick, so it should exit very quickly. Okay, so it exited. And now if I look in my logs directory, I can see there's a standard out and a standard error. Let's print the standard out. Okay, there we can see it ran on the compute node using the GPU to do the compilation or the calculation, or the CPU. You see this GPU is faster. That's what you expect. And so you guys need to make sure you're using those GPUs to do your calculations. Next, we'll talk about MPI.